Hello everyone, welcome to Old Mechanic Technical Workshop. Today, we will discuss the role of washing machine motors used in LG and Samsung washing machines, common failure symptoms, and inspection methods. When using a washing machine, you may encounter situations where the drum does not rotate at all, spinning does not start, or the machine stops during operation. Sometimes the motor may produce unusual noises, the drum may rotate weakly, or error codes may appear on the display. Many people immediately suspect a PCB failure when these symptoms occur, but in many cases the actual cause is a motor problem or a component related to motor control. The motor is one of the most important components in a washing machine. It generates the rotational force needed to wash clothes and spin the drum at high speed during the spin cycle. Without a properly functioning motor, both washing and spinning performance will be affected. Today, we will take a closer look at the motor structure, operating principles, failure symptoms, and diagnostic procedures used in LG and Samsung washing machines. First, let's talk about the types of motors used in modern washing machines. Older washing machines commonly used belt-driven motors connected to pulleys. However, most modern LG and Samsung washing machines use direct drive DD motors or BLDC motors. LG's direct drive motor connects directly to the drum shaft without using a belt. Because there is no belt, these motors operate more quietly, reduce vibration, improve efficiency, and require less maintenance. Samsung also uses Digital Inverter BLDC motors, which provide excellent energy efficiency, low noise levels, and reliable performance. During the wash cycle, the motor rotates the drum back and forth. During the spin cycle, the motor accelerates the drum to high speeds to remove water from the laundry. To achieve precise control, the motor works together with a Hall sensor and the main PCB. The Hall sensor monitors the motor's rotational position and speed, sending information to the PCB. The PCB then adjusts motor operation based on those signals. For this reason, the motor, Hall sensor and PCB are closely connected. Now let's look at the most common symptoms of motor-related failures. The first symptom is a drum that does not rotate at all. Water fills normally and drains properly, but the drum remains stationary. In this situation, the motor or motor control circuit should be inspected. The second symptom is a spin failure. The washing cycle may operate normally, but the drum cannot reach high spin speed during the spin cycle. The machine may repeatedly stop and restart or display error codes. The third symptom is a humming sound from the motor without drum movement. This often indicates that power is reaching the motor, but the motor is unable to generate sufficient torque. The fourth symptom is excessive vibration or metallic grinding noises during operation. These symptoms may indicate bearing wear, rotor damage, or loose mounting hardware. The fifth symptom is the appearance of motor-related error codes. LG washing machines commonly display LE errors related to motor or Hall sensor problems. Samsung models may display errors such as 3E or 8E, which are often associated with motor operation issues. When these symptoms appear, it is important not to replace the motor immediately without proper diagnosis. In many service cases, the Hall sensor is actually the failed component rather than the motor itself. Let's examine the most common causes of motor failures. The first cause is motor winding damage. Inside the motor are multiple copper windings. Over time, heat, moisture, and excessive load can weaken insulation and cause short circuits or open circuits. When this happens, the motor may lose power or stop operating completely. The second cause is a faulty Hall sensor. The Hall sensor detects the motor's position and rotational speed. If the sensor cannot send accurate signals, the PCB cannot determine motor status and may stop operation for safety reasons. The third cause is wiring or connector problems. Constant vibration and humidity can cause connectors to loosen or develop corrosion. Poor electrical connections can lead to intermittent motor operation or unexpected shutdowns. The fourth cause is PCB failure. Even if the motor is healthy, it cannot operate if the PCB fails to supply proper drive voltage. Therefore, the PCB must always be checked during motor diagnostics. The fifth cause is bearing failure. Worn bearings increase rotational resistance and create noise and vibration. In severe cases, the additional load may trigger protective shutdown functions. Now let's discuss inspection procedures. Before performing any inspection, disconnect the power plug and ensure the machine is completely powered off. Electrical safety should always be the highest priority. Begin by removing the rear or lower service panel and inspecting the motor connectors. Check for loose connections, damaged wires, corrosion, or signs of overheating. Next, measure motor winding resistance using a digital multimeter. Most BLDC motors have 3 winding terminals. Measure resistance between each pair of terminals. All readings should be relatively similar. A significantly different reading may indicate a damaged winding. An open circuit reading suggests a broken winding, while extremely low resistance may indicate a shorted winding. The next step is insulation testing. Measure resistance between the motor terminals and the motor frame. Poor insulation may indicate moisture intrusion or winding deterioration. Next, inspect the Hall sensor. Verify that the Hall sensor receives the proper supply voltage. While slowly rotating the motor by hand, monitor the sensor output signals. The voltage should change as the rotor moves. If there is no signal change, the Hall sensor may be defective. Visual inspection of the motor is also important. Check the rotor magnets for cracks or damage. Inspect mounting bolts to ensure they are tight. Rotate the motor manually and listen for roughness or abnormal bearing noise. Any grinding or resistance may indicate bearing wear. Finally, inspect the main PCB. Verify that motor drive voltage is being supplied. Look for burned components, damaged traces, or signs of overheating. If the motor and Hall sensor test normally but drive voltage is missing, the PCB may be faulty. Repair procedures depend on the diagnosed cause. A faulty Hall sensor can often be replaced separately. Wiring and connector issues may be corrected by cleaning or repairing connections. Damaged motor windings usually require complete motor replacement. Bearing failures may require bearing replacement or motor replacement depending on the design. PCB failures may require component-level repair or full board replacement. Preventive maintenance is equally important. Avoid overloading the washing machine with excessive laundry. Overloading places unnecessary stress on the motor and drive system. Maintain proper machine leveling to reduce vibration and mechanical stress. If unusual noises, vibration, or operational problems occur, perform inspections early before major damage develops. To summarize, the motor is the heart of the washing machine and is responsible for both washing and spinning functions. Motor windings, Hall sensors, wiring, bearings, and PCB components can all contribute to motor-related failures. When the drum does not rotate or the machine cannot spin properly, it is important to inspect the entire motor control system rather than focusing on the motor alone. That concludes today's presentation. Thank you.